And it will be not on HP1 or HPX, it will be on something completely different. And the presentation will be given by Susina Haile, and the floor is yours.
Yeah. Good morning or good afternoon. Yeah. I have in my PhD thesis, I have developed a new reactive transport model based reality, and in today's presentation, I will try to show the application of based reality for uranium leaching or reactive transport involving uranium. For the presentation outline, first we'll have introductions, and we will have a brief description about basic reality model. Then we will see the case, and finally we'll have resulting discussion and conclusion. So to start with, just brief information that we have about uranium. Uranium is a radioactive element which occurs naturally, and in the first half of the 20th century we used, or uranium has been mined for radium. Radium was used by that time for cancer treatment. After that, the first uranium mining boom was between 1940s and 1960s during the World War II. And during that time, a lot of uranium mining has been taken place, and the waste product of the mining has been deposited in different forms, and there are various environmental impacts associated with the uranium waste disposal. And among these environmental impacts, that due to air pollution, radioactive radiation can cause cancer, lung cancer, or pollution of water to cause serious problem. And to give an example, in 1994 in Australia, this Olympiad dam, which was a dam which was designed to store the waste, it released this much amount of uranium to contaminate the soil. And another example is in 2012 in Finland also there was such a problem, a uranium leakage problem which polluted the Snow River. And how this happens, in general, this picture can this picture with this is a general description in picture that shows the dangers associated with unsafe disposal of uranium. If we have a dam like this, there is gas, radioactive gas, which causes cancer. If the dam fails due to various reasons, from natural reasons or due to the problem with the construction of the dam, it may flow, and it contains highly contaminated toxic material, so it will pollute the nearby rivers or the soil. And if it leaks or if there is seepage, it will contaminate the groundwater. So such environmental problems could happen due to this tiling. And to simulate the possible, when we construct such a dam, we need to know the possibility of seepage, the possibilities of failure. And if we want to know what happens if there is a seepage, we need to use reactive transport models. And there are reactive transport models that we have seen today, HP1, HP2, and various. There are also for groundwater, for saturated zone like FAST. But inspired by FAST and HP1 for my PhD thesis or my PhD study, I have generated new reactive transport based reality by coupling existing reactive geochemical model Friction with base to T and base to H. Base to T is there a numerical model which simulates the transport of solute in variably saturated media, and base to H is a transport model which simulates the transport of heat in the variably saturated zone. And to couple or to integrate the heat and solute transport with Friction, we used non-iterative operator splitting approach, which was also used by FAST. And The new model has capabilities to simulate in addition to heat and solid transport, has capabilities to simulate various equilibrium and kinetic reactions which are incorporated in physics. So to see the application, I have taken a case, a hypothetical case, which was used also by HP2 in hydrogeochem. And in this case we have a soil, and here we have a uranium mine field, and here we have a river. And in this simulation or in this hypothetical case, we will try to see what will happen after a certain period of time if there is certain amount of, like, if we have such kind of infiltration which contains milling chemical solution, and if there is also infiltration, this much of infiltration of fresh water, and if we have the following pressure head and no flux boundary and no flux boundary, what will happen? For this, we have used this physical and chemical properties. By the way, I have integrated also this variably with Argus 1 so that we can create the user interface in Argus 1 and get also the output in Argus 1 environment, post-processing environment. So this is the input in Argus 1 environment. Here we used function hydraulic parameters for soil, and we use for both the soil and the tailing, we use the same hydraulic property and chemical property. And the solutions that we use for, this is a solution for the tailing, and this is a solution for the soil, and this is the solution at the boundary where we have rainwater or things like that. So this is the initial condition for flow due to the simulating processing tool. I couldn't generate the boundaries, but this is the water profile at the beginning, pressure head profile at the beginning of the simulation. And this is the uranium profile at the beginning of the simulation. That means we have high concentration of uranium in the tailing and almost zero in the rest part of the. And this is the uranium profile after 250 days. Here we see it's leaking. It reaches about 80 meters, but it still didn't reach the river. Here we see the uranium profile at 500 days, still didn't reach the river, but the groundwater is about 12 meters, so it has already polluted the groundwater. And after 1,000 days, it is approaching the river, but still didn't reach the river, but still completely polluted the groundwater. So, to conclude, we can use such kind of model to address environmental problems, environmental pollution problems like this, and reactive transport models can be used to see. It's not exact. The models we show, it's not exact. It's just a visualization, but to make to have an accuracy, we need to have proper initial conditions. We need to have the physical, chemical, and hydrogeological conditions have to be properly put. The initial and boundary conditions should be in proper way to, and in making decision, we have to compare as far as possible to with the result or measured values. So that's all. Thank you.
Any questions to this? There might be some because it was not Hydrus used.
Did you add two zones, you had saturated zone and non-saturated zone in the model?
Both variably-saturated, that means saturated as well as unsaturated.
So you combine between, because you showed that the plume goes like with the flow in the saturated zone, but doesn't go with the flow in the unsaturated zone, literally to the river.
At the beginning?
It's like 2 slides. Yeah, this one. So the red bit is going to vertically, and the plume goes like to the river, right? With the saturated zone flow.
Yeah, and
So this is what it means. Like, and where is the line between the saturated zone to the unsaturated?
the water table is at about 12 meters. I have shown you. This is an initial pressure head condition that this is the initial condition. The water table is about this. Yeah, can you see here?
Okay.
So the line is the
water, if you see the scale here, here is the pressure gauge is there here. So it's somewhere here.
So is that water
Sponge? Sponge is when I look down,
Second question was by Jenna. Any other? Is there a question or? Okay. Any other question? Okay. Yeah, if there is no more question, I think we can stop here for the lunch break. I think lunch is hopefully behind these doors.